means, and transformations. I know it's like 3 little mini topics. The first 2 are mini topics that, as I said, you're not going to really see in your homework tonight. Pretty much your homework is built on this idea of transformations. But I do want to put them in here because I feel it's a good part to at least introduce them. I'll redo them again, and I'll re-show it to you again because it's pretty. It's stuff you've probably done in your past in your basic algebra classes, Algebra 1 and Advanced Algebra. Finding a missing value when mean and n given. So we know that the formula for mean is the summation of x over n. I showed you this formula in the past. This formula also is the same and is equivalent to saying x1 plus x2 plus x3 plus dot 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 plus x to the n over n. Some of you just think of it as what it is. It's the sum all values and divide by the number of values. Some of you think of it in terms of have done it like that, but we need to look more in terms of the formula, and the formulas are given to you. All right. So in this example that we're about to do, in this example, I tell you that the mean is 72. And the values are 68, 75, 74, 70, and x. Find the missing value x. These could be quiz scores, for example. All right, so I have a 68, a 75, and this is very similar to the idea of if we added them. Now, if I were to find the average of the 4 numbers, 68, 75, 70, and 74, if I were to find the average of those values on their own, I would find out that that number is less than 72. All right? So what I'm trying to say is, if I were to find the mean of just these 4 values, I get a number that's less than 72. Okay? What does that tell you about x? If the average of these 4 numbers is less than 72, what does that tell you about x before we do any actual calculations?
Is less than the mean?
No.
Is it less than all?
No. You guys are all thinking backwards here. Think about how math numbers work. These numbers here, the average of these 4 numbers is less than 72. The average of all of the numbers, so let me write that down. So this is a more conceptual understanding of math and how numbers work. So the mean of the 4 known values is less than the overall mean of 72. Therefore, x must be what?
Around 72.
You don't know. You don't know that either. It must be more than 72. Everybody was saying it kind of backwards. Now, yes, this answer is the 4 values is actually pretty close to 72. So since the 4 values are kind of close to 72, then x must be also somewhat close to 72 as well. But when the basis of what I'm informing you is like, okay, I have these 4 students. They took a quiz. Their average is a 71. Okay, let's say that's what it was. It's not 71. It's something different. But let's say I think it's 71.8 or something like that. Their average is a 71. All right. I have another student who takes the test. Now the class average is a 72. What do I know about that student who just took the test? Well, I know that that student, and this is based on what we've previously known, that students brought the mean up. So if they brought the mean up, then that means that their value must have been higher than the mean. Since I know what the new mean is, they must have also have scored higher than that value in order to bring it up to that new value of the mean. So the 4 values have a mean less than 72. However, all 5 values have a mean of 72. So that means that the 5th value must be greater than 72. Now, why is that helpful? Well, you're going to have multiple choice questions. And this also happens on the SATs, all right? On standardized exams. You can use it. Sometimes you're like, oh, I don't have to do all this work. But if you look at that, you're like, oh, wait a minute, there's only one multiple choice answer that would make sense. If you look at all the multiple choice answers, it turns out that like option C is 72. So you get like 68, 71, 72, and then you see 73. And those are your only options. Well, without doing actually any detailed math or doing the problem like it's meant to be, you can be like, well, I know the answer has to be D because I know the answer can't be less than 72. Wouldn't make sense because if the average was already less than 72 and I added a number that was less than 72, then my mean is going to be less than 72. It also can't be exactly 72 because if the mean was already less than 72, but I add a new value that's exactly 72, it's going to bring it up, but not to 72. So this type of understanding is very critical in terms of how you think about numbers. Now, with that said, how do I go about doing this mathematically? How do I go about doing this problem as a math student? So there's a lot of things in stats. We can do things as a math student and think of it and just do all the, use the formula, solve the algorithmic type of steps. What I cherish more, what I find even more important is what I just talked about right there. It's not a math steps. It's not solving a problem, but it's understanding what answers should be around. In other words, if you get an answer of like 71, you're like, uh-oh, that's wrong. That didn't work. That couldn't be that. So that's something like that. All right. So how do I do this problem? How do I do this problem? No. I'm going to use the formula. And it says, hey, okay, the mean, which is 72, is equal to all of the values added together. Divided by how many numbers there are. So I just plug into the formula. Okay, plug into the formula. Now, if you're, it's not, if there's a formula, you need to be comfortable with using it. What is that?
So is 5 because it's a number, or the number was there?
Yeah, it's n.
It's 5. Okay, I didn't know.
N is how many numbers there are.
Yeah.
Same thing. This value n is the same thing as n was in before in our other problems. Okay, when we were doing parallel box plots or anything like that, n is n in all the entire course. It's how many elements, how many values that we have. All right, so what do I do now?
Yeah, I can hear you right now. I change it. So how broke on my internet?
Oh, I don't know what you were trying to say beforehand.
No, right now I cannot hear you.
Okay.
On my internet, I'm unstable.
Okay, I can't deal with that part. So, what what do I do as my next step?
Simplify.
Simplify, okay. So 72 equals, and if we pull out a calculator, what do I get?
I got 57.4.
No. You would do too much math. And
Too
you
much.
and because you did too much math, you did incorrect math. So you got to be careful. You got to take it step by step, and we got to do good math.
Okay.
So what Darwin said was correct. I'm going to simplify. Don't oversimplify because you can make bad algebra steps. So what do I get?
I think it's 287 plus x over 5.
Perfect. What do I do now?
Divide both 5 with 5.
You said it backwards.
So only divide 287 for 5.
No. You said what you said was kind of correct, but you said it backwards. Anybody want to help? What do I do in my next step? It's multiply. There we go. Multiply by
5.
multiply by 5 on both sides. There we go. All right. That gives me 360 equals what?
X.
No.
$287 plus X.
Yeah, 287 plus x. We don't do very much hard math in this class. This is typically as hard as the math gets. A 2-3 step math problem of solving for an unknown is about as hard as we get in calculus. I mean in statistics. Sorry. And finally, what I do is my last step.
Subtract the number.
So minus 287 from both sides. And I get that 73 is equal to x, and that is my answer. Okay. Use the formula. So we got to be able to utilize this formula in calculating it. This is we're not, like I said, I wanted to introduce it to you and show it to you, and that we can use the formulas in our understandings. And that's what's more important that I'm worried about today, is having an idea of, what cannot be not understood is if an answer makes sense, or what would be an answer that makes sense. And the answer needs to be bigger than this value. It needs to be between these values and so forth. All right. Overall mean. When given two population means, x1 bar, x2 bar, and their respective sample sizes that differ, and this is a big one, that differ, N1, N2, then overall mean is the mean overall is equal to N1 times x1 bar plus N2 times x2 bar, the mean of x2, divided by N1 plus N2. And I'll put parentheses around these just to make sure we understand. So this is our formula. The reason this formula works is we're kind of going backwards. So this is the N1 X1 bar is the sum of the values from that first population. N2 X2 is the sum of the numbers from the second population. So you want to find the sums. Just like when we found the sums was 287, it's the same thing right here. N1 X1 bar plus N2 X2 bar over N1 over the total sum, because that's how many I have now. So, it sounds a little bit tricky, but also, like I said, you can use, if you're struggling on the formula, if you're struggling on finding the formula, if you're struggling on memorizing the formula, if you're struggling on utilizing the formula, you can still, and the expectation is, have an idea of what the answer is if you if you understand the concept, and that's what's by far the most important piece. Example, 22 AP stat students in B block have a mean grade, have a mean grade of, let's say, 70. 12 AP stat students in C block have a mean of 80. Find the overall mean. Now, before we get into any calculations, can anybody tell me what my answer should be? What do I know? It's called like the domain or the range. What do I know my answer is? My answer is below, above, is less than this, greater than that, between this. I should have a choice that if I look at multiple choices, I should be able to have a grasp on what my answer is going to be. So, without doing the math, what is my overall average? What do I know about my answer?
Is it higher than 80?
Definitely not. That is complete. No, it cannot be.
Is it in the middle, like 75?
Okay. Well, so you were on the right track, but then you said a little too much again. So
In between 70 and 80?
So that's the first thing. That's the first thing I need to know. Yeah. So that's first level one. Level one understanding. If you understand means, level one understanding. It's between 70 and 80. All right. I have one class I average a 70, another class I average an 80. So my new average needs to be something between 70 and 80. Okay. That's the first level. My second level of understanding is that it was kind of stated, but stated incorrectly. So what's my second level? So I know it's between 70 and 80. Okay. What else do I know? I know more than that. And I know more than that. It's between. I know not only I can actually make that window smaller.
Is it something about the students? How many students will get between 70 and 80?
Well, we know how many students have gotten, so we want to find the new mean. So if I combine these two numbers, what would I get as my new mean? So we know the answer is somewhere between 70 and 80, and the number of students that have taken it. Now, if there was an equal number of students, let me give you this preface. If there was an equal number of students in both classes, if there was 10 students in period A or period B and 10 students in period C, then what would my mean be? That's an easy problem. That you've done that in the past. That's a basic algebra 1 type problem. If there's the same number of students and the average was a 70 and the average was an 80, what's my new average? Don't even have to do much hard math. I think it's very easy. You have class A has a 70, class B has an 80. There's equal number of students in each class. What's the new average? Or what is the average, as you would call it? It's how you calculate. So what would the average be? There's one student in period B, and there's one student in period C. One student got a 70, one student got an 80. Their average would be
Is it 75?
it would be 75, right in the middle. All right. If there was an equal number of students, it would be a 75. Okay. So I know my answer is between 70 and 80 because there's no mathematical sense that it could be anything other than something between those, because if you take something that's 70 and you average it with something that's 80, you're going to get something between 70 and 80. But if there was an equal, and I also know that if there was an equal number of students, which there's not, the answer would have been 75, right in the middle. That helps me because if I see an answer of 75 and you choose that one, I'm like, oh, that is, you got duped. So I would be able to cross, and believe me, the answer of 75 will be one of your multiple choice options. You're like, oh, okay, I know it's not that. All right. Now there's more students in B block than there are in the C block. There's more students in the class that got a 70 than the class that got an 80. Just write down what we said. And now the new one. Okay, so the answer must be, not the actual answer, but the answer must be what then? Cannot be 75, so I shouldn't. Is it bigger than 75 or less than 75? Why?
Bigger than 75?
Why?
Because it should be.
And that's why stats is so important, that why question. You get 0 credit almost every single time with just saying an answer with that a why. So, and I'm not saying that you're right, or I'm not saying that you're wrong.
Is it because the students in B block?
Well, so you agree with her?
Yeah, like it's a larger number in B block.
There's not a larger, yeah, there is a larger number in B block, so you're correct, but the answer is backwards. The answer must be less than.
70.
It must be less than 75, and because as Armani has said,
Probably 70.
because the sample size or because the size, because there are more students for the 70. We call this we call this a weight. It's weighted towards the 70. This is how grades work, right? This is how grades work. If you have something that has a higher weight, you can get, you got like tests and homeworks, and tests are worth more. And you got a 70 on your test. Your average for your test is a 70, and your average for your homeworks is an 80. Well, and maybe this goes through some of your answers. Some of you will come back and be like, why do I got less than an 80 then? I was like, well, your average test score is a 70 and your average homework grade is an 80. How do you expect to get higher than an 80, right? That's the same idea. Your overall mean is definitely not between a 70 and 80. Now, if I gave you a grade and the grade comes back and I say, you have a D minus in my class, and you're like, no, that can't be. That's impossible because my average here is a 70 and my average here is an 80. So I know my average has to be between a 70 and 80. That's okay, good, correct. And then you've got, I gave you a 73 in the course, and you're like, well, how is my grade a 73? I got a 70 and an 80. Shouldn't my average be a 75 then? And it's like, no. Math doesn't work that way. Average, and it's because there is more emphasis put on the test scores, so the average needs to be closer to 70 than it is 80. So I know this, and so this concept is something that should be very helpful for you to understand, not even just your grades, which progress reports were just posted, right? But also in terms of being able to make these calculations and reasonable decisions. So my answer is less than 75. My answer is between 70 and 75 in the end. And that's very helpful because if it's a multiple choice, there's likely only going to be 2 choices. And now you have a 50% chance of guessing rather than a 25% chance. So how do I do this problem the other way? Well, the mean is equal to 20 students who got a 70 plus 12 students who got an 80 over how many students are there now? If I combine them. How many students do I get now if I combine them?
32.
32, yeah. 32. All right. And I just plug this in a calculator. So I just go directly to my calculator. Just go to my calculator and do 20 times 70 plus 12 times 80 divided by 32. And I get 1,430. What happened? Does that make sense? Would I write that down on my paper? Would I write down 1,430 and move on to the next problem? What happened? What do I do?
You divide.
So I know my answer is wrong because my answer needs to be between 70 and 75. What did I do wrong? Well, how can I fix it?
Should you multiply first? So like you do the 20 times 70 and then you get your number and then you do 12 times 80 and then after that then you'd multiply, divide by 32.
So you got to be, that is correct, and you could do it that way. You want to try to utilize the technology features as best you can. One option using Z's method, I would just do that first part, 20 times 70 plus 12 times 80 and get that number and divide by 32 and do it that way. I put a wrong symbol. Sorry, 20 times 70 plus 12 times 80, get little fat fingers over here, and then divide by 32. 73.75, does that answer make sense? Yes, I know I've done something right. Or I can add an extra parenthesis beforehand and then do parenthesis 20 times 70 plus 12 times 80, close parentheses, divide by 32. Or, since I have an updated nice looking calculator, I can hit alpha y equals, hit enter, and I can input this as a fraction. As the formula intended. Oh, but it gives me that one. Let me just hit math and decimal. That gives me it. And if you don't ever like to give it, you can make it so that it always gives you. No, it doesn't have that here. So 73.75. Now, I could just say, here's a formula, and plug in the formula, and you get 73.75. Okay, that's not stats course, right? I am less worried about you getting 73.75, and I am more happier with you understanding that the answer is less than 75 but more than 70. I almost want to give that even a higher grade than just using the formula and getting 73.75. So when we talk about things like how do you explain your work, those are the types of understanding that not only tells me that you understand how to get the answer, but you understand what's happening. So when you're explaining things, when you're doing those verbal explanations like on your assessments, and you tell me things like, well, before I even start my problem, I know my answer is going to be, less than here because of this. That right there is like, all right, let me throw in some extra credit now, or let me, that even if you get the wrong answer in the end, you demonstrated that you have full understanding. There's things called typos. There's like, it's transcription errors. You understand everything that was happening. You plugged in the number wrong into your calculator, and all of a sudden, you got the wrong answer. Well, that's why AE should show your work, but also explaining. So this stuff I wrote here in red, these 3 things are very important in terms of your conceptual understanding. Okay. Let's continue. Transformations. Now this is different than what we covered in the past. So this is when a transformation is when all data values changed through some operation of addition, subtraction, or multiplication / division. When all of the values, all right, all of the values, so not just a single value. So in the problems that we studied back in chapter 4 and chapter 5, what we had done on those values was that one of the values changed. Okay, one of the value you added one new value. That's like outliers, right? Or you changed the value of one of the numbers. So that was the previous unit. What we're talking about here is that all of the values are changing. This, in its essence, is what this whole chapter is going to be based around, is around this idea of transformations. We are going to transform the data ourselves. But what happens if a transformation is given? Well, adding, or remember, subtracting. Subtraction is just the addition of a negative number. Is referred to as a shift. It's referred to as a shift. All right. So if this was like a 70 and I had all my data, and it looks like my data looks like this in terms of its distribution, and I were to add 5 to all values, then what happens, this is a shift, which is, it's called rigid. It's a rigid transformation, which a rigid transformation means what? What do I mean by that? What if it's just a shift? A shift is a rigid transformation. So what's going to happen with the distribution? Well, it's literally going to look exactly the same. In other words, it looks exactly the same, but now it's going to be centered where it was. This was 70 over here, and now it's centered at 75. Because if 5 is added to all of the values, then the new center is still going to be 75. Because it's a shift, what happens to the mean and standard deviation? So what happens to the mean and the median? Shifts result in changes for the mean and median. Now, in the above example, I added 5 to all values. I can also write this as y equals x plus 5. I took all of the values of x and I added 5. As such, my new median would be the previous median plus 5. My mean would be the previous mean, and whatever I do to it, it'd be the mean what? What would be my new mean? The mean what?
Plus 5.
Plus 5. What about, okay, so that's the big kicker. What about, what is my new, what's going to happen? What's my new minimum if I added 5 to all the values?
You subtract it.
What would be my new minimum? No. Don't overthink it. My new
That would
minimum.
be the old one plus 5.
What's about my new maximum?
Max plus 5.
What about my new Q1?
Q1 plus 5.
And you get the idea. These are values change with the transformation. However, and here's the big kicker. However, measures of spread do not change from shifts. Okay, so if the transformation is add 5, what is my new standard deviation? What is my new standard deviation for my new data? How has the spread changed? How has the spreadiness of the data changed if I added 5 to all of the values? And yes, I have kind of given you the answer. What is my new standard deviation?
The same as the last one.
Mm-hmm. And what is my new IQR?
The same.
What about my new range?
The same.
They are unchanged as data did not change spread. It only shifted. It was rigid. Okay. Multiplication / division. Division is just a multiplication of a fraction. Okay? Division is just the same thing as a multiplication of a fraction. This is referred to as multiplying / dividing data is a non-rigid transformation known as a stretch. Okay? It's known as a stretch. So for example, if I were to, i.e., if I were to multiply all data values by 5, y equals 5x, then if this is centered at 8, it will now be centered at what?
40.
40. And actually, I want to emphasize this a little bit more, just to be, so if you can erase that, I'm going to do it like this. Let's say it's on the same scale. So if this is what it looked like for here, and it was 8, and you see how the spread is very small, it's very compact, it's very consistent. My new spread would be around 40, but not only would it be around 40, but it's much more spread out now. Stretches result in changes of all non-zero summary stats by the multiplication / division. So, for example, my new mean would be equal to what? What would my new mean be equal to?
Mean times 5.
5 times the old mean. Good. What would my new IQR be?
The old IQR times 5.
Good. What would be my new minimum?
Minimum times 5.
And more importantly, what is my new standard deviation?
Standard deviation times 5.
And finally, what would be my new median? I didn't cover that one.
Median times 5.
Okay. If combining transformations follow the order of operations. The key here, the whole most important key here, SX, IQR, range, do not change with shifts. That's the big mistake everybody makes. The biggest mistake everybody will make, and if you make a mistake on your homework tonight, is because if I say, hey, you added 5 to the new data, what's your new standard deviation? And you're going to take the old standard deviation and you're going to add 5. That's the only way you're going to go wrong. The only place you should go wrong at. Okay? Let's end with an example. Okay? The following summary stats are based on the speeds of drivers who received speeding tickets in a 60 mile per hour zone. Okay, so in other words, the speed limit was 60 miles per hour. Everybody that we're going to talk about right now got a speeding ticket. Okay, so everybody got a speeding ticket. So that means that they were driving what? Every single person was driving Quick. We only got a minute.
Over 60.
Over 60. So my mean was a 70. My median was a 65. The standard deviation is 3. And the IQR was 4. Now, because the mean is bigger than the median, I know that this data is also skewed to the right, which makes sense because somebody was driving like 130 miles per hour is a possibility, and the lowest somebody can get a ticket is driving 61 miles per hour. So it makes sense that my median is bigger. All right. Tickets are calculated as miles per hour over the limit times $50. Okay? What's my formula? What's my transformation formula then? So Y is my ticket price. So Y is how much they're being charged. Y is the ticket. So Y is what? What's the formula that I'm going to do? It would be X
times 50.
close. It'd be X minus 60. Or in that times 50. Because I have to figure out how much they're gone over. Now I've given you, I know we're right at 10:50. Just give me 1 minute. This would be the formula. In your homework, I give you this formula. Okay, I give you this formula. Now, if you want to expand it, expanding it makes it much easier. But my question to you is, all right, what is my find the mean, median, standard deviation, and IQR of ticket cost. So all of these are in miles per hour. My answers are all going to be in dollars. Okay, just give me, like I said, give me the 1 minute. My new means are affected exactly as it is. So my new mean would be 70 minus 60 times 50. Okay, I do everything like normal. My new standard deviation, or my new median, would be 65 minus 60 times 50. However, my new standard deviation would be, I wouldn't subtract the 60. See, because remember, the subtraction doesn't matter. So it would be 3 times 50. And my new IQR would be 4 times 50, because it wouldn't make sense. And think of it conceptually. If you were to subtract 60, you get a negative value. You can't have negative standard deviations. Because the negative doesn't affect it. And all my answers would be in dollars. I don't want to keep you here too much longer. Your homework is posted into Google Classroom. Complete your homework. See you tomorrow. Thank you for staying the extra 2 minutes.